Free body diagrams, part 1 of 2. Our goal for this video, which is part 1, is to cover some details about drawing free body diagrams. Then we've got another video, part 2, and we'll see how those free body diagrams can be used to help us apply Newton's second law. So, what is a free body diagram? Well, to help us understand why something moves as it does, or why it doesn't move at all, it's helpful to draw a free body diagram. That's a diagram that shows all the forces that act on an object, not which the object applies, but which are applied to the object. A free body diagram also helps us when we apply Newton's second law, when we add up forces as vectors to find the net force. And again, that will be in the second video. So when you're drawing a free body diagram, we have two things you want to think about. If you draw a force on a free body diagram, what applies each of the forces that you drew? If you can't come up with anything, maybe that force doesn't really exist. Also, you want to consider the object's motion. When you draw your free body diagram, look at the overall picture and you say, is my overall free body diagram consistent with Newton's laws? In other words, if the thing is at rest, is the net force equal to 0? Does everything balance out? If it's accelerating in a particular direction, does your free body diagram show a net force in that direction? Okay, so here's an example. We have two boxes. A small box, box number 1 in pink, sits on top of a large box, box number 2, in green. You're holding these boxes, so you've got your hands underneath the large box. Okay? So first, consider the situation of you supporting the bottom box with everything at rest, and then in video 2 we'll actually go on and talk about what happens if there's an acceleration. For instance, you're standing in an elevator and the elevator is accelerating. Okay, we'll just do free body diagrams for the at-rest case to start with. So let's start with the free body diagram of box number 1. We're going to draw, by the way, 3 free body diagrams. The one for box 1, the one for box 2, and then for the 2-box system. So which forces act on box number 1? So the usual one that everybody gets right off the bat is there's a gravitational force, which we're going to label as M1G. That's the force that the Earth applies to that box. Then there's a normal force, an upward normal, that the lower box applies to the upper box. We'll label that Fn 2 on 1. Is there such a force like this? Do you apply a normal force? Well, we like this one. We like this one. We don't like this one because your hands are directly under box number 2, so you're not directly in contact with box number 1, so there is no such upward normal force applied by you. There'll be one on box 2, but not on box number 1. Okay, so there's our full free body diagram when we put everything together. Downward gravitational force and an upward normal force applied by box number 2 on number 1. Note that the force is balanced here. That's consistent with no acceleration. Okay, so let's consider now the free body diagram of the second box. Again, we'll start with a gravitational force. That's the force the Earth applies to box number 2. We'll label that M2G. M2 is the mass of box 2. This time there is a force, a normal force, applied by you on box 2. Okay, because your hands are underneath box number 2 supporting the weight. That's quite a large force. What about a downward normal force applied by 1 and 2? Or should we label that as a downward M1G force? Okay, so let's think about which of those is the right way to do it. We like this one. The Earth applies a force to box number 2. We're thinking about all the things that box 2 interacts with. The Earth, you, the other box. We like all those 3 forces. We're not going to go with this one. Now there's 2 good reasons why we label the downward force applied by 1 and 2 as a normal force, not an M1G. One is the fact that that force arises from contact between the 2 boxes, and the normal force is one component of the contact force. So that's the type of interaction that really is represented there by the 1-2 interaction. And the M1 g-force represents an interaction between the Earth and box number 1. It does not belong on box 2's free body diagram. Okay, now if there's no acceleration, you're absolutely right that M1g and Fn 1 on 2 will turn out to be the same number. But if there is an acceleration, those two things will be different. So you want to make sure you really get the right one. Okay, so you want to label that downward force as a normal force applied by 1 on 2. Okay, so there's the full free body diagram. Upward force applied by U, downward force applied by box 1, downward force of gravity applied by the Earth. Again, the net force should be 0 if everything is at rest. Okay, what about the two-box system? So we'll treat the two boxes as one system. There's a combined M1 plus M2 g-force, and there's an upward normal applied by U on box number 2, but that's part of the system. And that's it. That's all we have to consider. Okay, we don't have to consider any internal forces. Okay, so we can think of the two-box system free body diagram as the combination of the individual diagrams, box 1 and box 2's. So let's look at those. There's the box 1 free body diagram. There's the box 2's free body diagram. Now wait a second, is the last picture the one for the two-box system? The sum of those two things? Let's see. So there's the upward normal force. That's right. These two downward gravitational forces, we can combine into a single gravitational force, M1 plus M2, all times g. What about these things? Well, oh, right, Newton's third law applies here. So those two are equal and opposite. They're internal forces when you put the boxes together. So we don't actually have to consider them on the combined system free body diagram. Okay, so that's a good example of how to draw free body diagrams in a particular case. We've got a two-box system. We looked at the box 1's free body diagram, box 2's free body diagram, and the combined systems free body diagram. And then we'll go on and we will use those free body diagrams to help us apply Newton's second law and write down equations in the next video, which we labeled Part 2.